With this video, we begin the series on the synthesis of gabapentin and pregabalin. This series includes an introductory video, videos of retrosynthesis, and resulting synthesis. Here we present the systematic name, CAS number, and the structure expressed in 2 and 3 dimensions of gabapentin, which we can be considered as a derivative of gamma-aminobutyric acid, better known as GABA. Gabapentin does not have asymmetric carbons. Pregabalin can also be considered a derivative of GABA, and unlike gabapentin, it has an asymmetric carbon with the S configuration. Both drugs have a history in the gamma-aminobutyric acid, a neurotransmitter better known as GABA. As can be seen, both drugs can be considered derivatives of GABA as they have substituents in the 3 position of GABA. However, gabapentin was created with the idea of being analog of GABA and mimicking its neurotransmitter function. But to the surprise of its inventors, it acts on a different receptor than GABA, and the same was true for pregabalin. In this way, the 2 drugs owe their activity to binding to the alpha-2 delta subunit of voltage-gated calcium channels, attenuating the release of glutamic acid, an excitatory neurotransmitter, thus reducing excessive hyperactivity associated with seizures. Regarding its structure-activity relationships, we can visualize the structure of GABA substituted in its 3 position as a pharmacophore. The substitution at position 3 was originally intended to provide lipophilic groups that could cross the blood-brain barrier since GABA cannot do so. Gabapentin was developed as analog of GABA, patented by Parke-Davis, introduced in the U.S. by Parke-Davis, now Pfizer, with the brand name Neurontin. Pregabalin was created by researchers of Northwestern University. The university licenses Parke-Davis for its development. Introduced in the U.S. by Parke-Davis with the brand name Lyrica. Both drugs are indicated mainly for the treatment of neuropathic pain and as adjuvants in the treatment of epilepsy. Other specific indication for each drug are those shown here. Both drugs are given orally, but pregabalin has a very good absorption, while gabapentin is variable and dose-dependent. Their plasma half-lives are in the range of 5 to 7 hours. Both drugs have common adverse reactions such as drowsiness and dizziness, and they have some rare reactions that can be severe and require medical surveillance. Some relevant physicochemical properties for both drugs are shown here. In the following videos, their retrosynthesis and the resulting synthesis will be presented. Thank you for your time.